Hi, this is Garth. We're going to look at putting a knowledge pattern into a Powercopy, and this knowledge pattern is going to instantiate a simple UDF. Take a second and set up some geometrical sets that look something like this here on the left. Now we can get started. I'm just going to make a couple points, one at x equals -20 here. And let's do another at x equals 20. Alright. And now let's start building our strut PC here. It's going to be our strut Powercopy. Let's go into this geometry set. Let's make a line between these 2 points. Let's, for visualization purposes, just a construction line. Okay. Now let's make a point on that line, and let's say that it's always going to be the ratio of 0.5. Alright, now let's make a translate here of this point. So let's go to translate, take our point, let's go in the, actually I was going to go in the ZX direction here, but instead of this, let's cancel out of this, and let's just make a sort of reference line to use as a direction. So in this one we want to do a angle normal to curve, choose that curve, default support is okay, and take our point there, make it 90 degrees, and 25 feet. It doesn't want to support, so I guess the support is going to be the XY plane, which is fine, so it's always going to be drawn on that XY plane. Alright, so we're actually going to use that curve as our translate direction now, so that we always translate normal to this baseline. So let's take our point again, start to translate, and direction will be in that line. Let's say distance can be 25 feet, 20 feet. And now actually let's make a parameter to control that distance. So come up into here. New parameter of type length. Click the button, click OK. That gives us this length parameter. Let's take this down in our parameters. Call it translate length. Let's call that 20 feet. Let's double click our translate again, and right click, edit formula, set that to be the parameter. Okay, so now this parameter is driving how far out that point goes, and let's just get that formula down into our Powercopy set. Alright, so we can change that and the point will change. Good, that's all linked. Alright, so now let's make a circle. We're actually just going to make an arc, but the circle definition is what you use to make all these things. Alright, so we're going to take a 3-point circle, and we're going to click that base point, this translated point, and the other base point, and that's going to give us our arc. And then let's make a symmetry of that arc. Our reference will be that. Alright, so now if we change that translate length, great. Alright, so now let's just hide some of this geometry that we don't need. Let's also hide our 3 planes here. And let's hide this line. And actually we don't need to see this translate anymore. Or that point. Alright. Okay, sorry I keep pausing the recording here. There's a lot of stuff going on in this room right now. Alright, let's actually let's show that center line for now. And show that point, because we'll use that point as the base point for our UDF just for now. Alright, let's make our line UDF now. Define in work object. And this UDF is just going to be a line. We're doing this all in wireframe now. You can build complexity with these concepts later. So let's make our UDF also normal to curve. Choose that curve. Let's just make that the base point for now. Support will be the XY plane. Angle is 90 degrees, and then this up to. This is a good function here. Rather than being always being a fixed distance, let's make this up to. Just go up to the circle, and then we're going to say we shouldn't actually need an up to 2. We should be able to say mirrored extent. Let's see what's wrong here. Okay, let's uncheck that. Alright, so let's actually do this on the end up to. There we go. So when we do an up to with mirrored extent, we need to make the end value the important one there. Alright, so that's our line UDF. This is just a stand-in for some sort of, say, structural member. So let's make a UDF out of this. So its inputs are that point, which is its base point, the circle, the line, and the XY plane. That's okay. Here, let's call this line UDF and auto line UDF generate. Okay. Alright, so let's hide our original one and just make sure that this works to be manually instantiated. Alright, so the circle, the point, the line, and the XY plane. Alright, that did not go as well as I thought. Give me a second. Alright, no problem here. All I had was I had the line UDF geometrical set hidden. And then I actually instantiated the line UDF into that set, so it didn't show. But when I click on that, I can see that it put a line UDF there. So I'm just going to delete that. Now I'm going to hide this set. And Now I'm going to get into making a knowledge pattern that's going to instantiate this. So let's go into product knowledge template, get ourselves a knowledge pattern. Alright, first let's just add a list that I know we need to add. It's going to be called UDF list. And now a bunch of terms we'll need. Let I integer. What we're going to do is make a bunch of points along this line and instantiate the UDF on all those points. So let PT be a point. We also want to make it so that it's a even distance between these members, and the amount of them will change depending on how long that line is. So let's say let spacing be a length, and let mem number just seems like too long a variable, so let's just let num be a integer. Okay, so let's say spacing equals 10 feet for now, and let's say that our actually, before we get too far with this, I'm just going to hit OK, and let's bring our knowledge pattern into this Powercopy set. Alright, sorry again for all the stopping here. Alright, now let's just do a little math to get all our spacing right for these pieces. So the number of pieces is going to equal the length of this main line divided by spacing. But then we want to make sure that whatever this is, this number returns an integer. So I'm going to add this function that's int, and then put whatever you want to be an integer in parentheses, and that essentially rounds the solution to this to the nearest integer. And now we're just going to make one more term. Let's call it let ratio be a real, and ratio is going to equal 1 over the number, and we're going to use that ratio to divide our curve. Alright, so now let's start a loop for I while I is less than num parentheses. We're going to make a point on the curve to use as our base point. So PT, remember we declared that variable as a point, equals, now let's go to, where was it here? Point constructors, and this point on curve ratio, and it's going to ask us to input a curve, like a starting point, which we'll just use our first input point as the starting point there. let's get back to this info. It's going to ask for a ratio along the curve. So we have a ratio term, but we want it to move each time it goes through the loop. So we're going to say I times ratio. And orientation, say true here. If you find it's making all the points at one end, it means it's trying to go in the wrong direction and has no more additional curve to go with. So whenever that happens, you can go in and try to change true to false, because that true false toggle just affects the direction. So now we're going to use that point and the rest of the base geometry of the Powercopy to instantiate a UDF. So let's go to generative functions. We want to create or modify template, and line UDF in quotes, which we just created. Destination can be this UDF output here. The next one, here, I'll bring this back up. The next one is the list that it wants to go in. So that list, and it could just be at position I. So now that we started this command, let's go into the language browser. So I'm not getting this in my language browser. It's because I didn't declare it up here as a variable. So let's let my line be line UDF. Let's say it's saying there's an error there. So let's get to the bottom of this for a second. Okay, here I quickly see the problem. Sorry, you might have noticed this as I was typing it in. We need to set something equal to this creator modify template. So my line equals creator modify template, and then my line should. There we go. Now I'm getting the inputs I need. Sorry for that. It's early in the morning here. My brain's not moving quite as fast as I'd like it to be. So now let's just set these attributes. Circle is going to be so I set that equal. My line, let's say 0.5 equals, and this is where I'm going to put in the variable PT that we just created up there. My line 1 is going to equal XY plane. Okay, now this space in this XY plane is going to cause an error. It's going to be ran into this because a lot of people have been having this trouble. So I'm just going to hit OK and press no. And before you do any major scripting, it's good to delete the spaces in these names or create your own planes with their own names based on these planes. But you don't want to be referencing these in a knowledge pattern when they have that space. So actually we need to update this UDF and auto-generate again. So we should be able to now let's see, that should have updated. I'm not sure why it didn't. So we renamed that. I'm just doing this all again, hoping. So doesn't seem to be working out very well, so I'm actually just going to remake the UDF. Sometimes it's better just to remake instead of struggle through those problems. So let's give it the name line UDF. Now we see that's okay. Auto UDF generate. Alright, so now in our language browser we finally have an XY plane without the space. That was a bit of a struggle, but we got there. So now we're just going to set the XY plane equal to the XY plane. Okay. And we're just going to need to and modify template here for my line. I equals I plus 1. Alright, so let's see if this works, and if not, we'll go back and troubleshoot it. Alright, so we have our strut geometry there, and we have an knowledge pattern that should instantiate these. Good, and this worked. So we can go back in, and if we change this spacing to 5 feet, and let's put this on automatic execution. Alright, so this is working well. And then if we change, say this to it didn't seem to like us changing that to 15. Undo a couple times. So it seems to like it there. Let's move one of these points. Oh, now I'm on auto update. Alright, so it's got a problem with our list, so let's go back in and alright, so the problem it's coming up with is I never set I equal to 1 before running the loop, and it'll often give an error if I don't do that. Alright, so now this seems to be working okay. Again, running into these problems here is good so everybody can see. I just double clicked too many times and created a problem there. So I'm just moving these points and changing that translate length. Alright, so it looks like the knowledge pattern is working fine. It's automatically updating. So now we're going to make a Powercopy out of this strut PC. And I'm going to click on that geometrical set, insert Powercopy. It's asking for 2 points in a plane. That's fine. Alright, so let's just make a new geometrical set and call it PC output. Okay, so now let's just make some more base geometry. Let's put that point, I don't know, here. And now let's instantiate another one of these struts between this original base point and this new point. Let's go in our Powercopy here, instantiate point 3, point 4, XY plane. So what it's doing is instantiating a whole new set and running that knowledge pattern. You know, we can make this as long as we want, and it keeps adding members as we need it to. And then we can do stuff like nest these if you want to. Let's make another couple of points. Let's say I'm just making these quickly as base geometry, but you can embed this sort of thing into the intelligence of your Powercopy and knowledge pattern. Let's make a point that end of that member and one at that end. And now let's instantiate the Powercopy between that point and that point, XY plane. You can see that one's a little funky, but we can go back in and change. Let's change that to 5. And we can go back into the knowledge pattern. This can also be an outside variable if you want it to be. Let's change the spacing to, you know, so you can see how we can nest these things, and that using actually very simple geometry, you can build a lot of intelligence into a Powercopy and have a knowledge pattern in there, and then you can go back and update your UDF to make more complex geometry. So thank you for bearing with this tutorial and all its stops and starts. Enjoy.